Okay, this is Dr. Morton giving you a demonstration of the RS Latch. So if you look at the schematic here in Logisim, you'll notice that we have two NOR gates. One NOR gate, one NOR gate has a push button input. When the push button is not pushed, it's inputting a 0. When it's pushed, it's inputting a 1. And I can give it a little push over here by pushing on it like this, and it puts in a 1. And notice when I do that, it turns that little connecting wire green going into the input. Notice that this wire is already green, which means that we have a 0 here when the button's not pushed and a 1 here going in. Now the way I always think about a NOR gate is I think about the first part of it's just a standard OR gate and then a bubble on the output. So I always ask myself, what is the gate outputting before the bubble? Well, in this case, since it's an OR gate and one of the inputs is a 1, it's a 1 before the bubble, and after the bubble we invert that 1 and we have a 0. Notice the 0 has feedback into this other NOR gate, which has feedback then into the first NOR gate. Now since the second NOR gate here has a 0 from the output of the first one and a 0 from the button, before the bubble it's a 0 and after the bubble it's a 1. The 1 turns on this LED and then it's fed back, and that's why it's a light green, because it's a 1 going into this first NOR gate. So because this one's being driven with a 1 and this one's being driven with a 0 and the buttons are both inputting 0s, in this configuration it's very stable. Now notice what happens. So we call these inputs the S input and the R input, and the output from this first NOR gate is the Q prime, and the output from this one is the Q. In this case, Q is 1 and Q prime is 0. So we would say this RS latch is set, and that's what this button here does. It sets it. Now if I punch the R button, it's going to reset it. And notice what happens. It's going to take this Q that's now a 1 and it's going to turn it off and turn this one on and make the Q prime a 1 and the Q a 0. And watch. Now what's going to happen when I let go of this button? When I let go of this button, it's basically going to resolve. It's going to stay in this configuration. It doesn't really matter. I can push this button all I want. It doesn't change anything now. But if I push this button, it does. So if I go back to the reset state, in this state, Q is 0, Q prime is 1. Notice Q and Q prime are always the opposite of each other. Now, what happens if I change some things? Let's see if I can undo. I can't redo. Okay, well, all right. So I'm going to modify this circuit now. And here's what I'm going to do. I am going to, I think I'll add an input. So I'm just going to, so let me do that. So what I'll do, I'm just going to take out this button right here. I'm going to delete it. And then I'm going to connect a wire from here . Yes.
Are you recording? Sorry. Okay, sorry.
So what you can see, I've connected a wire from this one button to both of these. So what I'm going to do is I'm going to put a 1 into this one and a 1 into that one. Now look what happens when I do that. Oh, I can't do it. I have to use the poke button. Sorry. Okay. When I do that, I'm driving a 1, but both of these are 0. So now look, Q prime and Q are both 0s. But remember, they're supposed to be the opposite. So that's a logical impossibility. Q and Q prime should never be the same. And then look what happens when I let go of the button. It puts it into some kind of strange oscillation mode. And so that's why, now in many cases I think that with real components this might settle into one of the stable states, but we don't know which one. But in addition to that, it might also oscillate. So I'm not so sure what would really happen in real life, but the potential for oscillation is there. All right, so let me undo this, and then I'll reset the simulation, and I'll enable it. All right, so now we're back to where we were. So what I want you to see, a couple of takeaways from this. Number one, that we get this memory effect. It comes from the fact that we have two stable states that we can create, and then without changing the inputs, it'll stay in that state. Secondly, that it involves feedback in order to get this effect. And thirdly, that in this simple configuration, we have the possibility of putting a 1 in at the same time, and so that we have the potential for instability, and we call that then a forbidden state. So what we're saying is this works fine as long as you never let S and R both be 1. And so S ANDed with R not equal to 1. All right. So that completes this brief demonstration of the SR latch. When we draw this latch, we usually draw it as just a box, and we don't show the NOR gates. And we usually draw the S and the R, or sometimes the R and the S, and often we put Q opposite the S, even though it actually comes out of the NOR gate where S is the input. But that doesn't really matter on the symbol that we use in most schematics. All right. We'll end with that.